Hello. Today we're going to talk about the second type of problems from section 1.8 that might be giving us a little bit of trouble. Finding angles when given the exact values. Just like the last type of problems, we'll take a look at the steps we're going to need to follow. Here we go. First, we're going to need to determine the quadrants that the angle might lie in. What we do is we take a look at what the sign of the value is to determine where our angles are going to lie. Second, we're going to determine the x, y, and r values using the definition of the trig function. Third, we're going to draw out the reference triangles and determine the reference angles. And finally, we're going to use those reference angles to determine the angles in standard position. So let's go ahead and start taking a look at this. First things first, I see we have the sine equals -1/2. Well, the sine of any angle is negative only in quadrants 3 and quadrant 4. So I like to set up my two sets of values, quadrant 3 values and quadrant 4 values. Step 2 says we're going to determine the x, y, and r values. Well, sine is y over r. So when we write our x, y, and r values here, I see that y is either 1 or -1, and r is equal to 2 or -2. The problem is we have to remember that r is always 2, which means y has to be -1. Not only for the quadrant 3 answer, but also for the quadrant 4 answer. Next step is to figure out what x is. We can always go back and use x squared plus y squared equals r squared. And we plug in x squared plus -1 squared equals 2 squared. X squared plus 1 equals 4. We subtract 1 from both sides, we get x squared equals 3. And when we take the square root of both sides, we get x equals plus or minus square root of 3. In quadrant 3, x is negative square root of 3. In quadrant 4, x is positive root 3. We now have our x, y, and r values for the two angles. Now we need to draw out the reference triangles and determine the reference angles. So let's start with our quadrant 3 value. So when I look at this, quadrant 3, x is negative root 3, y is -1, and r is 2. Well, this is obviously a 30, 60, 90 triangle because of the values we have for the triangle. And opposite this -1 is our reference angle right here. And opposite 1 is 30 degrees. Let's take a look at the quadrant 4 answer. In quadrant 4, we have x is positive root 3, y is -1, and r is 2. Again, we see the 30, 60, 90 triangle, but now again, opposite our y value here is our reference angle, and that's 1, so this is going to be 30 degrees. Final step is we want to figure out what this angle is from standard position. Rotate around until you hit your terminal side. Well, from here all the way to here is 180. We're going to go 30 more. So in quadrant 3, we're going to do 180 degrees plus 30 degrees, or 210 degrees. Quadrant 4, start on the positive x-axis and rotate around to here. We're going to go all the way to 360, but go 30 less than that. So we're going to do 360 degrees minus 30 degrees, or 330 degrees, which is our end of step 4. Let's take a look at another one here. Again, we have the cosine of theta equals root 2 over 2. When is cosine a positive number? In quadrants 1 and quadrant 4. Positive. So our quadrant 1 and our quadrant 4, let's set up. Now one thing I notice is this value here seems to be rationalized. I mean, we got root 2 over 2. To make our lives a little bit easier, I'm going to take that root 2 over 2 and rationalize the numerator by multiplying by root 2 over root 2. That gives me 2 over 2 root 2, or 1 over root 2. Our definition of cosine is x over r. So in this case, x has to be positive 1 in both cases. R is root 2. And again, if we plug into our x squared plus y squared equals r squared, we will find that y is either positive 1 in quadrant 1 or y is negative 1 in quadrant 4. Again, don't forget, you can always check that by plugging in here and solving for your y. So now let's draw those out. Quadrant 1, we have x is positive 1, y is positive 1, and r is root 2. You notice our x and y are the same, which makes this a 45-degree reference angle. In quadrant 4, we have x is 1, y is negative 1, and r is root 2. Again, we see that 1, 1 for our two lengths of our right triangle, which makes this a 45, 45, 90. The final step, we need to figure out what the angle is. Well, from standard position, if I start on my positive x-axis and rotate until I hit my terminal side, I get this angle here, which, guess what, is in fact 45 degrees. It's nothing to do. Our reference angle and our actual angle in standard position are exactly the same in quadrant 1. In quadrant 4, we start on our positive x-axis and we rotate around until we hit our terminal side. So we're going to go 360 degrees, but go less than that by 45 degrees. So 360 degrees minus 45 degrees is 315 degrees, which is our two answers. Let's do one more here, and I want to give you a special one here. So again, tangent equals 0. Uh-oh, we can't determine the quadrants because we don't have a positive or negative. How are we going to handle that? Let's jump to our definitions. Tangent is y over x, is it not? Well, in order for tangent or y over x to be 0, y must equal 0. There's no doubt about it. It has to be 0. What we don't know is what x is. X could be any number we want. Not only that, it can be any positive or negative. So you know what we're going to do? We're going to put a positive 1 in one case, and in another case, we're going to put a negative 1. Y has to be 0 here. So let's figure out what r is going to be if we do that. X is 1, y is 0. We get 1 squared is 1 plus 0 equals r squared. R squared equals 1. If you take the square root of both sides, you get plus or minus 1. But remember, r has to be 1. It has to be a positive number. And in both those cases, if we had plugged a negative 1 in here, we still would have gotten the same answer. So we do get two answers here, but they're not in quadrants if you look closely at this. So let's make our two coordinate planes. Let's take a look at this first case here. If x is positive 1 and y is 0, guess what? We got a point right here. If that's on our terminal side, that's right here. What angle is that? Yeah, it's just 0 degrees. The next one. If x is negative 1 and y is 0, that point's going to be on this terminal side. Well, what is this angle? You're right. It's 180 degrees. It turns out that this value gives us two quadrantal angles. Well, there you have three examples of how to find exact values and exact angles when given exact values. Hopefully this helps you out with your homework. Let me know.